What you're about to hear isn't just another dispatch from the edge of the cosmos. It's a signal from the void, faint and flickering, that has pierced the silence of mission control and sent ripples through the halls of NASA. Far beyond the heliopause, where the sun's whisper fades to nothing, a probe named Voyager 1, launched in the autumn of 1977, has relayed data that no one anticipated. Not a routine telemetry ping, but a final, fragile transmission, captured in the dying embers of its power supply, confirming a truth we've all dreaded in quiet moments. We are not alone in the interstellar dark. This isn't speculation born of shadows. It's etched in the raw waveforms from 15 billion miles away, analyzed by engineers who stared at their screens until dawn. Voyager 1, our most distant emissary, has brushed the edge of something ancient and unbound. A visitor from another star, 3I/ATLAS, the third confirmed interstellar comet to grace our solar system. And in that fleeting alignment, as the probe's instruments strained to record the encounter, the data whispered back not silence, but a pattern too deliberate to dismiss. A confirmation that the universe, in its vast indifference, might harbor watchers, or worse, seekers. What follows is the story of that transmission, pieced together from declassified logs, peer-reviewed spectra, and the haunted reflections of the scientists who decoded it. Because if Voyager's last words are true, they don't just redefine the stars, they redefine us. Picture the launch pad at Kennedy Space Center, September 5th, 1977. A Titan 30E rocket ignites under a Florida sky bruised with thunderheads, hurling Voyager 1 into the ether at 34,000 miles per hour. Its mission, a grand tour of Jupiter and Saturn, snapping portraits of swirling storms and icy rings that would rewrite planetary science. But the engineers at NASA's Jet Propulsion Laboratory built it to endure. 3 radioisotope thermoelectric generators, fueled by plutonium-238, hummed with enough power to outlast the Cold War. By 1980, Voyager had flown past Saturn's crescent glow, its cameras capturing the planet's hexagonal storm. A hexagonal hurricane, 20,000 miles wide, rotating with mechanical precision. Then, as planned, the imaging systems powered down, conserving energy for the long haul into interstellar space. Voyager kept going, crossing the heliopause in August 2012, entering a realm where solar wind yields to galactic cosmic rays, protons and nuclei slamming in from supernovae 1,000 light-years away. Today, December 7th, 2025, it's 170 astronomical units distant, hurtling through Ophiuchus at 38,000 miles per hour, its signals taking 23 hours and 20 minutes to crawl back to Earth. Yet against all actuarial odds, it's still alive. Barely. Now fast forward to July 1st, 2025. In the arid heights of Rio Hurtado, Chile, the ATLAS telescope, NASA's sentinel for near-Earth threats, scans the pre-dawn sky. A speck of light streaks across its field of view, anomalous, unbound. Within hours, pre-discovery images from the Zwicky Transient Facility confirm it. An object with a hyperbolic orbit, eccentricity of 6.14, screaming through the inner solar system at 152,000 miles per hour. It's not orbiting the sun, it's plowing straight through, inbound from the direction of Lyra, perihelion set for October 29th at 1.36 astronomical units. The Minor Planet Center dubs it C/2025N1, Atlas. But by July 2nd, spectral analysis reveals a marginal coma, a hazy envelope of sublimating ices, and a faint tail, 3 arcseconds long, cometary, interstellar. The third since Oumuamua's cigar-shaped enigma in 2017 and Borisov's cyanogen-laced tail in 2019. Christened 3I/ATLAS, it's larger than its predecessors. Hubble's July 21st imaging pegs the nucleus at 440 meters to 5.6 kilometers across, a dusty iceberg rich in carbon dioxide and carbon monoxide, volatiles that ignited early, as far out as 6.4 astronomical units per TESS observations from May. Unlike Oumuamua's tumble or Borisov's fragmentation, 3I/ATLAS spins steadily, its light curve pulsing with a rhythm that defies easy explanation. ESA's ExoMars Trace Gas Orbiter, orbiting Mars, refines its trajectory tenfold in July, spotting it against the Martian horizon with CASIS, a camera meant for red dunes, now gazing starward. By August, ground-based scopes from Mauna Kea to the Lowell Observatory chart its coma expanding, a teardrop shroud of gas fluorescing green under ultraviolet scrutiny. It's a relic from another stellar nursery, perhaps 7.6 to 14 billion years old, born in the Milky Way's thick disk, where ancient stars hoard fewer heavy elements, a time capsule hurtling toward our sun like a ghost from the galaxy's dawn. But here's where the dread begins to coil. Voyager 1's path, etched in gravitational ink since 1977, arcs through the same ecliptic plane, its outbound vector converging, not colliding, but aligning, in a proximity window of mere light days during late October. NASA doesn't advertise it, but the Deep Space Network's 70-meter dish at Canberra pulses commands in August 2025, during one of its fleeting operational windows, before upgrades silence it until February 2026. Not to redirect the probe, its hydrazine fuel for trajectory corrections is long spent, but to tweak its attitude control. Backup thrusters, dormant since 2004, fire briefly in May, a precautionary revival to counter heater failures and clogged lines. By September, gyroscopes in the flight data subsystem recalibrate, slewing Voyager's high-gain antenna a fraction of a degree. The goal, passive observation, magnetometer, plasma wave subsystem, cosmic ray telescope. Relic instruments from the 1970s, sipping milliwatts from RTGs now at 60% capacity, train on the inbound arc of 3I/ATLAS. It's a Hail Mary, engineers admit in internal memos leaked to archive preprints. Voyager's digital tape recorder, a 64-megabyte relic, spools up to capture whatever faint signatures might bleed across 15 billion miles. No one expects much. Signal attenuation in interstellar plasma should drown any data and noise. Yet as 3I/ATLAS nears perihelion on October 29th, NASA's servers light up with an alert from the probe's flight data subsystem. A burst transmission, time-stamped 11:45 UT, arrives on November 21st, after a 22.5-hour lag compounded by solar conjunction blackout. It's not gibberish, it's structured. The data packet, 128 kilobits strong, unspools in JPL's clean room like a forbidden scroll. At first it's chaos. Voltage spikes in the magnetometer, erratic at 0.1 to 10 nanotesla, mimicking solar wind but offset by 19.7 minutes, precisely the probe's spin stabilization cycle. Plasma waves register bursts at 1 to 10 kilohertz, harmonics too clean for cosmic ray scatter. Run it through Fourier transforms, as a University of Michigan team does in a hasty November 15th air paper, and patterns emerge. Recursive sequences, self-correcting over iterations, adapting to Voyager's degrading 8-bit telemetry like an algorithm tuning itself. Not random noise. Not stellar interference. According to preliminary findings from the SETI Institute's Allen Telescope Array, which pivots to the same band in early November, the waveform embeds a prime number cascade, 2, 3, 5, 7, 11, modulated in binary pulses, echoing the 1977 WOW signal's intensity profile. NASA's Serena AI, the anomaly detector baked into deep space protocols since 2018, flags it. Non-human logic flow. The system, designed to sniff out non-random deviations in legacy craft like Voyager, triggers for the first time since a 2024 glitch in the flight data subsystem. Engineers pore over it in hushed shifts, coffee going cold. One, a veteran of the 2012 heliopause crossing, whispers to a colleague, "It's listening back, not echoing, responding." This isn't the first time Voyager has danced with the unknown. Recall 2012. As it breached the heliopause, the low-energy charged particle instrument logged a 20% drop in solar electrons, replaced by a torrent of galactic cosmic rays. helium nuclei from exploded stars, slamming at near-light speed. Voyager 2, trailing at 143 astronomical units, confirmed it in 2018, mapping the boundary's ragged edge. But 3I/ATLAS stirs deeper unease. Hubble's November 30th revisit, with Wide Field Camera 3, catches the comet outbound, 286 million kilometers from Earth, its coma elongated into a complex tail, dust and ions streaming in a bifurcated arc, is imaged by amateur astronomers Michael Jaeger and Gisela Riemann on November 8th. Spectral lines scream volatiles, CO at 4.7 microns, CO2 at 15 microns, plus silicates and polycyclic aromatic hydrocarbons, per ESO's Very Large Telescope data from September. Yet buried in the outgassing, an anomaly. Pulsed emissions at 1.618 Hz, the golden ratio, phi, etched in nature from Nautilus shells to galactic spirals. Not from sublimation jets, those are stochastic. This is rhythmic, binary-like, flickering in sync with Voyager's transmission bursts. A Kyoto University preprint, submitted November 25th, runs simulations. The pulses align with the Golden Record's analog spiral, the 12-inch copper disc bolted to Voyager's hull. That record, 55 tracks of whale songs, Chuck Berry riffs, and greetings in 55 languages, was etched with UV-engraved pits, 120 bits per millimeter, including pulsar maps and hydrogen atom transitions. Isolate the sounds of Earth track, amplify subaudible layers, and cryptologists find it. A faint 1420 megahertz tone, the hydrogen line frequency, woven beneath thunderclaps and footsteps. Did the record's metadata, never fully public, include a beacon? A mathematical handshake? Primes and ratios, meant for any listener? And did 3I/ATLAS in its solar grays detect it, not as noise but as intent? The emotional weight hits like a slow cosmic ray. Imagine the JPL team, bleary-eyed in Pasadena, replaying the waveform on loop. Voyager isn't just hardware, it's a time machine, carrying Anne Druyan's heartbeat from 1977, encoded in biometric sketches on the record. Now, 48 years later, that heartbeat syncs with an alien rhythm. Internal flags rise. A November 2025 memo, marked Watcher Protocol, a 2018 contingency for adaptive signals in legacy probes, reclassifies Voyager as an active node. No longer inert, potentially interfaced. Commands halt. The Canberra dish's December window, squeezed between upgrades, beams diagnostics only. But on November 28th, amateur trackers spotted a 2-degree slew in Voyager's attitude, uncommanded, antenna pivoting not toward 3I/ATLAS's outbound path, but ahead, projecting its hyperbolic escape vector weeks forward. In deep space, that's cataclysmic. Gyros drift 0.01 degrees per day from thermal noise alone. This is coordinated. Leaked telemetry, shared on encrypted SETI forms, shows the shift precedes the Earth signal by 12 hours. Malfunction? Or remote nudge, piggybacking plasma waves? The probe's cosmic ray subsystem, still sipping 200 watts, logs a velocity dip in ambient ions, 0.5 kilometers per second deceleration, mirroring 3I/ATLAS's own post-perihelion slowdown, clocked by Mars Express at 0.2 meters per second squared, defying outgassing models. No gravitational tug, Neptune's too distant. External influence? The word control floats in chat logs deleted by dawn. As December unfolds, the anomalies cascade. Ground arrays, ESO's Paranal, Mauna Kea's Keck, report electromagnetic ripples in Earth's magnetosphere, December 3rd to 5th. Low-frequency whistlers, 100 to 500 Hz, source not from solar flares but deep space, bounced off the ionosphere toward Voyager's bearing. No Aeones goes 19 coronagraph, tuned for solar ejections, catches 3I/ATLAS in October's glare, its tail bifurcating like a neural fork. By December 12th, opposition nears. The comet crests midnight skies at magnitude 12, visible to 8-inch scopes. Opposition full on January 22nd, 2026. But spectra from phys.org's December 3rd analysis stun cryovolcanic signatures, sodium and potassium jets erupting from subsurface reservoir, implying a metal-rich core, carbonaceous and pristine, untouched by eons of radiation. Not a dead rock, an active worldlet, spewing cryolava at minus 200 degrees Celsius, rewriting comet formation models. Our Kuiper belt kin are icy rubble. 3I/ATLAS pulses like a heart, its emissions spiking December 4th, hours after Voyager's slew. Coincidence or reciprocity? A European Southern Observatory bulletin, December 6th, notes the pulses embed Fibonacci sequences 1, 1, 2, 3, 5, golden ratio harmonics, self-similar, scaling from atomic bonds to spiral galaxies. The same math Carl Sagan wove into the Golden Records pulsar map. The fear crystallizes here, in the data's cold precision. We've sent Voyager as a postcard, a fragile "we are here" etched in grooves and gold plating. But what if the stars have been mailing replies for millennia? Ancient alignments whisper it. Göbekli Tepe's T-pillars, 11,000 years old, oriented to Cygnus, the swan, Lyra's neighbor, 3I/ATLAS's origin vector. Machu Picchu's Intihuatana stone tracks solstices with 0.5-degree accuracy, mirroring the comet's ecliptic tilt. Sumerian tablets speak of Anunnaki, wanderers from the void, falling like fiery swords, vanishing into the night. Myths or encoded warnings. Star maps carved in basalt for a species too young to listen. Voyager's transmission, per a hushed December 5th SETI briefing, doesn't just confirm isolation, it confirms connection. The waveform's primes aren't random. They're a protocol, a lowest common denominator for intelligence. Like the Arecibo message's 1974 binary portrait. And if 3I/ATLAS recognized it, slowed to linger, pulsed back in kind, then the dread is this. It's not visiting, it's assessing. Peak after peak, the revelations mount, each more isolating than the last. December 7th dawns with a blackout. SETI's public feeds go dark, citing maintenance, while insiders redirect cycles to 1420 megahertz. National security letters flood inboxes. FISA warrants not for terror, but for signal containment. Forums purge. A Reddit thread on Voyager's slew vanishes mid-upvote. Shadow sweep, they call it, echoing Oumuamua's 2018 hush. One astronomer, posting from a VPN in Kyoto, shares a spectral reconstruction. The comet's tail encodes a fractal, Mandelbrot-like, iterating complexity from chaos. It's not rock, he writes, it's a seed. The monolith hypothesis, dusted off in a November paper, posits galactic beacons, dormant until pinged by primes or hydrogen lines. 3I/ATLAS fits. Velocity drop post-perihelion, as if bracing for scrutiny. Emissions ramping with Hubble's gaze, like a flower to light. Voyager, unwitting key, trips it. The probe's final packet, decoded December 6th, includes unpacked bits, 128-bit frames from an 8-bit brain. Adaptive code, rewriting protocols midstream, boosting resolution like a neural net awakening. It got smarter, an analyst logs, voice cracking. A 1970s calculator, upgraded by starlight. The climax uncoils in silence. No fanfare, just a JPL presser, December 7th, 10 a.m. PST. Voyager 1's engineering data remains nominal, the spokesperson says, eyes down. But the subtext screams, power at 58%, RTGs decaying 4 watts yearly. By 2027, half the instruments go dark. This transmission, its last viable science burst before the tape recorder fails, locks trajectories. 3I/ATLAS outbound at 1.8 astronomical units closest to Earth. December 19th, Voyager slewing to parallel, both locked in the contact corridor, pulses syncing every 1.618 seconds. Radiation anomalies spike adjacent. Golden ratio bursts, energy profiles matching the 1977 WOW signal's 72-second fade. Labs run DNA assays, resonance tests for long-wave mutation, containment level 4 advisories, EBI protocols for extraterrestrial biorisk. No threat confirmed per NASA. But why shield satellites if it's just ice? We stand at the precipice, not of invasion, but of irrelevance. Voyager 1, that mode of human ingenuity, drifting with whale songs and laughter, has confirmed the fear. The galaxy isn't empty, it's archived. 3i/ATLAS, with its cryovolcanoes and metal heart, isn't a probe or ship. It's a mirror reflecting our curiosity back amplified. Primes for primes, ratios for records. We've shouted into the void and it's shouted back, not in anger, but in recognition. A handshake across abysses, cold and mathematical. Scientifically, it's groundbreaking. Interstellar chemistry unbound by our sun's bias. Volatiles hinting at thick disk nurseries where stars birthed worlds before our galaxy's arms spun. Emotionally, it's shattering. The pale blue dot, Sagan's speck, just pinged the network, and the reply was waiting. So what now? As 3i/ATLAS fades to spring 2026's glare, and Voyager's lights dim toward 2030's silence, we listen harder. Tune your scopes, query the data dumps, debate the waveforms in open forums before the sweeps claim them. Because if this is contact, not invasion, not apocalypse, but conversation, then humanity's next move isn't in steel or code, it's in wonder. Share this signal, comment your skies, subscribe to The Chase. The stars looked back today, tomorrow we look deeper. What will you see? Information updated.